Hello and welcome to Mindscapes, our series of programs that are conversations with men and women whose ideas, vision and philosophy define our contemporary world. My guest today is the head of the Department of Neurobiology, Communication and Learning and Memory at the National Center for Scientific Research at the University of Paris-Sud. I'm delighted to welcome Dr. Serge Laroche. Welcome. Did I get all of that right?
Yeah, absolutely.
Okay. Tell me, you work in the area of memory and how the brain retains ideas, images, concepts, words. What is the basic mechanism of memory?
That's a very complex question.
My goodness, that's the area of your...
more than half an hour to answer that. But, I mean, basically, one thing is that the brain doesn't just take information, it creates information. We create information in our brain.
In what ways? That's amazing.
In what way? Because each time we perceive something, a perception is not just a projection on a mental screen. It's an interpretation is based on our own history, so we recreate the information in our brain. And if we are in front of the same event together, we may not have the same memory of it exactly. I mean,
Let me take this sort of step by step. I have the information that you are sitting here in front of me. These images are received through my eyes, through the retina, through the biochemistry of perception. It sort of goes somewhere into my brain. And then how do I retain that as a memory? What are the processes involved?
The process involves using one system of memory, which is called episodic memory. That's where we record all our individual experiences. Our organs, like the eye, is perceiving sensory information. And this activates cells in the brain. And these neurons, the only thing they can do is to emit a little electricity that we call an action potential. And they fire, and they send this action potential to other neurons. We have billions and billions of neurons in our brain. This is a very complex machine. So the activity in these sensory areas are conveyed to more associative areas that are going to associate the view with the smell, with the words we pronounce, with everything around, to make a single souvenir. So the first aspect of memory is just activating specific cells, and probably a huge number of them for each type of memory, activating them so that they transmit information to others and make a specific network that is emerging over the noise in the brain as a selective pattern of activity in some cells. Now, to keep that memory, the electricity is producing by a chemical process changes in the neurons that are activated.
You know, you'd mentioned that the brain creates information, but isn't this on the basis of accumulated memory, or are you making a case for reincarnation, that there is some ways a carry forward, that we are born with a residual memory of some kind?
Well, first of all, we construct our brain during development. When a young child hasn't got the same brain as it's going to have after 10 years, there is a very slow process of construction of the brain. And every time we memorize something, we modify the connections in our brain. So we have a brain that changes all the time. So this is purely the individual memory. But each time we're going to memorize something, it's on the basis of our history of memorizing things. And we interpret events based on our history, and we encode these events based on our history. This is the biological memory. Now, on top of this, there is the evolution memory, which is the evolution that has been built over, the memory that has been built over evolution, and which is purely genetic. It's encoded in our genes.
Now, are there sort of techniques that we can use to enhance memory? Can the brain in some ways be trained so that memory is enhanced? Some people have better memories than others. What is that a function of?
We can improve our memories mostly during development, because this is where we need to first construct our brain in a certain manner. So if you learn to play the violin when you're very young, you may become a very good violinist. If you don't, there's no chance that you may become a top-level violinist. So there's an element of development which is important. Then, for the normal individual, we build our memories and we can improve it by several means. First of all, to remember something, we need to pay attention to it. And attention is something that we can control. We can voluntarily pay attention to something or not pay attention to something. And we can train ourselves to pay more and more attention to certain things than to others. So this is an element of training. We need also a brain that is healthy, and for that we need not to be too tired, otherwise we don't memorize very well. We need a little stress is good for memorizing, but not too much. There's an optimum level of the function of the brain, which requires a lot of neurotransmitter system, molecules that are released in the brain to make it work efficiently, but not too activated, otherwise it's detrimental to the memory. So we can improve it this way.
Is it possible to improve memory through the use of chemicals? There's a great deal of work being done on the biochemistry of the brain in terms of treating mental illness, for example. So can we sort of pop a particular pill that will deliver a chemical that will improve our memory?
At the moment, I would say this is a dream. This pill does not
exist.
But a
realizable dream, you think?
There's a possibility, but I don't think it's the purpose of the research at the moment to improve the normal memory. The main purpose of the research that we do is to find molecules that would compensate for memory deficits in patients with lesions, or during aging, or in patients with neurodegenerative disease. This is a major health problem, how to improve a memory that is affected, that is altered. And this is the main point of pharmacology, and it works in certain cases. But improving the normal memory of the human being, I don't think it's the aim of the research.
So in what ways do chemicals go in there and improve or work on the biochemistry of the brain to improve memory deficiencies?
Yeah, there's several different ways. It depends on the alteration in the brain. If you have somebody with Parkinson's disease, which is a lack of an enzyme in the brain which makes a chemical that is essential for some parts of the brain to work normally, then there's a pharmacological treatment which works pretty well, which is dopamine, the lacking molecule. So the patient will take dopamine and they improve. The major alteration in this patient is lack of motor coordination, but at some point they'll have cognitive deficits as well. And this, giving them dopamine through pills will improve tremendously their behavior. And the problem these days is that after a while they need more and more dopamine, and it doesn't work as efficiently. So the very newly developed technique is to implant electrodes in the brain and stimulate the cells that are not making enough of this dopamine. And up to now, it works perfectly well. These people are recovering to completely normal behavior, normal ability to learn and remember, with just a little electrical stimulation of some neurons.
You have also done work on aspects of communication and the ability of human beings to communicate with each other. To what degree is this purely, again I use the word biochemical, what transpires in the brain, and to what degree is a function of emotion, of tastes, of culture, of sensibility? Are all these biochemically imprinted in the brain?
Emotions are certainly biochemically imprinted in the brain. Culture, no. Culture is another type of memory. It relates to what we call meta-memory, is the way how do we know our memory works. can we make a representation of a representation? An animal can't do that, but we can do it. So if you explain to me in details how this TV camera works, I don't know how it works, but I can make a representation of it because I hear the specialist telling me how it works. But this doesn't require chemical. It's just a way of using our brain. While emotion is basically chemical. We release hormones and molecules in our brain that are making something either painful or very enjoyable, and this is very important for memorizing events. We don't memorize so much neutral events. We memorize either difficult or favorable events, and the more they are enjoyable, the best we can remember them, but also, of course, the more painful they are, the most we remember them.
Do you then subscribe to an emerging belief in people working in the areas of the brain that mental illnesses such as depression are largely biochemical,
Yeah.
and should be treated biochemically?
I believe that. I believe that depression is really, there is a chemical basis of it. I don't mean that it's the trigger. I mean, the trigger is obviously a lot of circumstances in life that changes the way our brain works, and I can't explain to you how it does that. But at the end, there's a chemical problem, and this can be cured by pharmacology.
What about then the notion of consciousness that sort of transcends the merely sort of empirical understanding of the workings of the brain?
The brain and memory is still a mystery for a lot of people, but consciousness is an even greater mystery. We can only have theories about consciousness. I personally believe that consciousness, to a certain extent, emerges from biological materials. Nerve cells produce consciousness. So there is consciousness even in animals. I have no doubt with that. By working years with animals, I can see that. But we have another type of consciousness, is that we are conscious that we are conscious of our own consciousness, which animals don't have. And how does it work in the brain? I don't know, and we don't know. It's just an emerging property of the work that our brain does, which provides a new function that is to be aware of.
What about the aspect, and this is what I was alluding to when I mentioned culture, what about aspects of morality, of ethics, of compassion? Where do you think that these sort of arise from and govern and motivate human behavior? Where do they figure in this sort of neurobiochemical structure?
I'm not sure there's any scientific and biochemical answer again to that question, because our brain is a machine that is made to store information and use it. The way we use it, it's our choice. So compassion is something we can decide to have or not to have, depending on how we want to behave.
Do you sometimes ever feel sort of limited by your understanding of the brain, or I was going to use the word defeated in some ways, that it's limiting and it can't explain everything, so maybe we should all ascribe this to a god or a higher or a different or a parallel consciousness, no matter how we decide to describe God?
Well, this won't be the attitude of a scientist. Brain science is a very young science compared to any other type of science. It's only, less than 100 years that we know what a neuron is, really. So it's a very young science. And it's true that we know very little, but that's also what's made this type of research so exciting, because our knowledge is improving tremendously over the years. mostly with the availability of new techniques like brain imaging in humans, in living humans. You can see the brain at work. By molecular biology also, which now we can see some genes that are modified when we learn something. And we change in our neurons the expression of certain genes to make new proteins, to change our circuit in the brain. How does this relate to the higher levels of cognition like consciousness, awareness? This we don't know, and we're still lacking experimental means to study them, first of all, and lacking a biological conceptualization of what an emergent property can be.
Do you think that, that this study has the potential of intervening and making people more ethical, more efficient, more productive through the use of chemical manipulations or electrical stimulation of particular centers of the brain? Do you think that potential realistically exists? Is it something that you fear?
I think there might be a potential, and I would fear it. And I don't think it is in the human project to do these sort of things, like genetic manipulation of humans or whatever. Again, the purpose is to help people. This is what a human being is here for, is to help other people. So helping curing diseases, of course, this is our aim. Changing human beings, I don't think so.
Even if for the better?
Who will define what is the better? That is the major problem.
There is this sort of debate already happening in many parts of the world on to what degree you can go in for techniques such as cloning, whether human cloning is worth doing or not. And the scientific establishment in many countries are driven by commercial imperatives, which means that if you don't participate in a particular form of research, whether it's ethical or not, you're just going to be left behind. As a researcher, do you face ethical dilemmas of this kind?
Absolutely, yeah. It's a question that we have to ask ourselves regularly. And the example of cloning is very interesting because many countries have decided not to do human cloning. And then recently some decided to do some human cloning, but for a specific purpose. What they're going to do is clone human cells that are going to be used to replace organ transplantation. So with this aim, and if it stopped there, it's not to make another human being, it's to make a few cells. And it works, because if you implant these new cells to a patient who needs a new liver, for example, it will recover an efficient liver. So it's a nice way of doing it. But it has to stop here. If one day we were to decide to really do cloning and make humans as we want them to be, I would fear that a lot, and I won't participate in such a program. But I'm really optimistic, and I think humans everywhere are clever enough not to do it.
You know, sort of 100 years ago, it may have seemed science fiction for someone to transplant a heart if a heart was diseased. Do you think that something like a brain transplant might be possible one day, and what its implications might be?
Technically, why not? But there will be another problem, is who is the person?
Exactly.
Is it the brain, or is it the body? So I don't think we're ever going to solve this problem. So presumably we'll never do a brain transplant. We can inject some cells, try to repair some cells, maybe genetically by injecting cells that are genetically modified, but we'll never, I think, implant a brain into a body.
Even though it might one day technically be possible.
Even if it was technically possible, yeah.
There's been a great deal of writing, at least in popular scientific literature, and I use the word popular, that looks at the insights that say the Eastern traditions, the Eastern philosophical, mystical traditions offer into Western scientific empiricism. Do you believe that there is some substance justification in this, or is this just stretching things? I refer to things like, Fritjof Capra's Tao of Physics, The Dance of the Woolly Masters. There's a whole lot of literature that is looking at what contemporary scientific research has to say about meditation techniques. Can they alter the biochemistry of the brain? When people go into processes of deep meditation, there are physiological changes that can impact the brain. So it's not just sort of chemical interventions that happen, but there is something that we can do ourselves to repair or to alter the biochemistry.
Yeah. Well, that's possible, but the only problem I have is that I don't contest the efficacy sometimes of these methods. The problem is that they have never been analyzed scientifically to try to understand how they work. So it's difficult to give an answer because we can stay at the level where, well, something works, we don't need to understand it, or we may want to understand it. Personally, I'm on the side of those that would like to understand it in biological terms. But this has to be studied specifically, and it's not the case at the moment, I think.
In terms of your own work and aspirations as a scientist, you have been focusing very deeply and profoundly in the workings of memory. What discovery, what sort of hope, ambition do you carry for yourself that if you feel you have achieved an insight, an understanding, that a life's mission will have been fulfilled?
Well, I think presumably the understanding of some of the molecular mechanisms of memory is going to be a great help to designing novel therapeutic ways of curing certain neurodegenerative disease, like Alzheimer's disease, for example. And, well, this could be a nice thing to do.
Do you fear for yourself that a time may come when sort of your brain cells become completely inactive, and common terminology would describe that as death? Would you just see that as just a cessation of electrical activity in the brain, or something more? Or?
Well, clinically, death is cessation of electrical activity in the brain. Now, we don't feel our neurons firing, but they fire all the time. And if they stop firing, we don't feel it either.
But do you fear it?
Fear that they may stop?
Yes.
Well, they will one day. I'm not particularly fearing it.
And is there something that you do you pray?
No.
Do you come from a family or a tradition that has been spiritual or religious in some ways?
Yes.
And how have they responded to your more empirical approach to?
I don't know. In our tradition, it's quite open, and everyone is responsible for his own choices. So that was quite easy.
And if you were to make a prediction for the next we're at the beginning of the century. In what form, shape do you see human beings by the end of this century in terms of their ability to intervene in deficiencies and malfunctions of the brain?
In 100 years' time?
Yes.
I mean, it's very difficult to project that far.
Of course, but just a fantasy, a vision.
But I think most of human diseases will be cured in some ways, in terms of at least, I mean, even cancer or these sort of diseases. And one major thing will be to keep aging without any problem, so that we can age normally without losing our memories, without feeling more and more pain in our body. This would be, I think, a major development.
Do you think it's possible that we will reach a stage where we're able to reverse aging, halt aging perhaps?
I don't think so, no. What we have to do is to make aging nice, not to